Here's another article that's not related. I just did a Google search or a search on that same organism that article was talking about, or one of them. I think there was a total of three. Um, they kind of go back over uh, some of the ideas of its anti-inflammatory processes because of its producing butyrate or short chain fatty acids. And they kind of indicate that this particular bacteria constitutes 5 to 15% of the gut microbiome, which is more than I've read. I thought, well, that's kind of news to me because, again, you always hear the lactobacillus strains, the bifidus strains, and occasionally you read about some strains that, people are trying to sell something, so they're putting those strains in. But they really will talk about this. And again, the part of the problem with this bacteria is that it's almost impossible to put it in a pill to give to somebody. Let's see, what did they say on? They talked about the volume of published articles on PubMed. There's this huge amount on gut microbiome, which is becoming more and more studied, and more things are being uncovered about it. There's the relational value to how many studies on butyrate, and this particular bacteria, the one I can't pronounce, is just a speck on the whole thing. So, but it looks like they're coming up with more and more research studies on this, and stuff that was covered in the other article. Butyrate synthesis. Oh, that's interesting. I don't think that was covered in that article, but enzyme production, that it can help in other metabolic functions. Well, I guess that was immune modulation, anti-inflammatory functions. Nothing that wasn't already covered. T-junction proteins to prevent. Oh, there was about the leaky gut. The barrier depends upon T-junction proteins to prevent the contents of the gut leaking into the bloodstream. Butyrate encourages T-junction proteins by activating this particular chemical. Let's see what else they have. This is these microbes can produce this chemical, which is found in plants, that's able to protect against inflammation induced by LPS bacteria. And LPS bacteria are kind of a problem. They stimulate an awful lot of very high inflammatory process. Or they say LPS bacteria, or LPS, are toxins on the external membrane of some bacteria, not all bacteria, that can activate the immune system and cause inflammation. This is kind of interesting that it can also make these, I'm not going to try to pronounce it, which will help prevent bacteria from creating biofilms. And biofilms are a whole other subject in themselves. If you have biofilms, typically biofilms come into the mucous membrane. If you have biofilms, then microbes can hide, or pathogenic organisms can hide under that biofilm, which stimulates constant immune system activation because the immune system is trying to get to them, and they cannot because the organisms will hide it to the biofilm. So there's an awful lot of research has been on biofilm destruction, and again, these biofilms tend to get in mucus areas, so the intestinal tract can be up in the sinuses and so forth and so on, and they can be a big problem. They can just create massive inflammation. Let's see what else they say. They're mentioning that low levels of that bacteria are involved in Crohn's disease and also ulcerative colitis, which they know that these diseases, these IBS, inflammatory bowel diseases, are due to some kind of immune system activation disruption in the microbiome. Let's see what else. Um, or they say that the presence of elevated levels of bile, which is coming from the liver, gallbladder, and its components can also affect its abundance. Colon rectal cancer, diabetes. A lot of people are indicating a lot of these metabolic diseases, uh, diabetes, the POTS or orthostatic uh, diseases are coming from the rootedness in the immune system activation. And they're indicating that states have identified imbalances in the gut, uh, which is just triggering all this inflammation. And that's about it on that.